And now we will talk about absolute value of a number. It's also called modulus of a number. Its absolute value of a number is represented by the number between two vertical bars. It's nothing but n if n is greater than 0. It's equal to 0 if n equal to 0, and is minus n if n is less than 0. So it's nothing but, it's the same number if it's positive, if it's the negative of the number if it's negative, and if it's 0 if it's 0. So I say absolute value of 7 is equal to 7. Absolute value of minus 5 is equal to 5. Absolute value of minus 7.2 is plus 7.2. Absolute value of pi is pi. Okay. And certain things which we can note here is absolute value of x plus y, where x and y are any two real numbers, is absolute value of y plus x. Of course, x plus y is equal to y plus x. That's not a big issue. And absolute value of x minus y is equal to absolute value of y minus x. And absolute value of x plus y is always less than or equal to absolute value of x plus absolute value of y. And absolute value of x minus y is always greater than or equal to absolute value of x minus absolute value of y. And absolute value of x into y is equal to absolute value of x into absolute value of y. And absolute value of x by y, where y is not equal to 0, is equal to absolute value of x by absolute value of y. And this is for the concept of absolute value is for real numbers. We have a similar concept for complex numbers. That's called magnitude of a complex number. Let's say we have a complex number a plus ib. The magnitude of this complex number is called a square plus b square under root. Okay, and say we have okay, we represent z by a plus ib. Then modulus of z, if you come to the same notation, modulus of z, which is called the magnitude of the complex number, is defined by this. And one thing which one can note is a complex number multiplied by its conjugate is a square plus b square, which is nothing but the magnitude of the complex number squared. And now we have come to an end of this boring review lecture. Now we will talk about basic arithmetic operations. The four basic arithmetic operations we have are addition, subtraction, multiplication, and division. I don't think I need to define this, but anyway, to make it clear, we have two numbers a and b. Adding two numbers a and b will give the sum of numbers, and subtracting a and b, subtracting b from a will give you the remainder, or the minuend of the two numbers a and b. And when you multiply two numbers a and b, we get product. When you divide a and b, we get coefficient. Of course, we also get a remainder if a is not a product, is a multiple of b. And I would also like to stress on something here, difference of two numbers a and b. When I say a minus b, it's not difference between a and b, it's the minuend of a and b, or remainder obtained when I subtract b from a. The difference between A and B is the absolute value of A minus B. So if I have two numbers 7 and 5, the difference between them is 2, which is nothing but 7 and 5. 7 minus 5. And when I have two numbers 4 and 9, the difference between them is 5, which is 9 minus 4, which is nothing but the absolute value of 4 minus 9. And the last thing which we are going to discuss now is the Bodmer's rule. If you remember, it's bracket of division, multiplication, addition, subtraction. This you must have learned in primary school. And actually something which we have to learn is V Bodmer's rule. V is nothing but vinculum or bar. So we will start something like this. Let us say we have a number, say 2 plus 3 into 4. So which one I have to do first? Is it 2 plus 3 then multiply with 4, or 3 into 4 and then add 2? If we do these two first, then we have 5 into 4, which is nothing but 20. If we do these two first, then it's 3 into 4, 12 plus 2, it's 14, which is right. In this case, we go with Bodmer's rule. We go this way, left to right. Which comes first, multiplication or addition? Multiplication comes first. So we need to do this first and then add. So this is wrong. And let us say we have an expression something like 2 by 3 of say 9 into 4 plus 6 into 3 bar plus 2 divided by 3. So suppose I have something like this. Then what I have is, first I need to remove the vertical bars. First I have to remove vinculums, there's bars, so this will be replaced with 8. And then we'll go with brackets. Bracket has to be removed. That means whatever is inside the bracket has to be done first. And actually this is off, not bracket. The brackets come into picture when you have something like 2 plus 3 into 4 divided by 2. Something like this. When you have something like this, it's brackets first, then multiplication or division. So first solve what are in the brackets. So 2 plus 3 is 5 into 4 divided by 2 is 2. This is nothing but 10. So here this is not actually bracket, this is off. 2 by 3 of 9 into 4 plus 18 plus 2 divided by 3. And then after bracketing it off, we have division. So 2 by 3 is 3. So 2 by 3 of 9 into 4 plus 18 plus 2 by 3. After division we have multiplication, so we do this 36. After multiplication we have addition, so 36 plus 18 plus 2 by 3. 36 plus, okay, whatever, now we can do, so we have, let's say we get a number 8. So the final answer will be nothing but 2 by 3 into 8. That's all. And this concludes the revision of very basic fundamentals of arithmetic. Hope you weren't bored much. And we'll have another video session where we solve few problems based on this, which is not very obvious. And later on we'll move to the next concept. Thank you.